Hi guys, welcome to this Rhino modeling tutorial. So just the first, so there's two types of modeling as discussed in class earlier, and that's surface modeling and stereotomic modeling, shown here. Which is also just another name of that you would call carving out of mass. That's what stereotomic means. So, great. So just a few things before we get started. I highly recommend everyone to turn on Snappy Gumball. Right now I'm using Rhino 7, but the same settings should appear in Rhino 8 if you select this white circle in your gumball and just select snappy dragging. That way things align or snap, and you can hold control to move just the gumball, so you can change your reference point, and you'll just have more control with moving objects on your Rhino screen rather than just typing commands all the time. Like you don't have to type move, type rotate. Like you can just use the gumball tool with Snappy. It's very powerful. So yeah, especially for surface modeling, I highly recommend it. So the first thing you'll do is you'll take one of your diagrams and you'll see like a detail that you like, or whatever detail you discussed with your TA. You'll start to outline the basic edges in that image, right? For now, I started with a simple polyline. That way, as you could see, I could easily control the points and control the depth of this curve here. And so, right, once you do that, you'll see that I can move these curves to however I like. These will begin to be my sweep rails. I know it can get confusing. What's a sweep rail? What's a sweep curve? But we'll get to that in a second. So right now we're gonna start with our sweep rails, okay? And normally I click on the object and you'll see the vertexes. That's usually enough. But if you like to see all your points at once, I also recommend just typing the command points on. So you'll see your points even when it's deselected. So I'll type points on. And it's just nice to see your points so you know where to click. And yeah, I'm rotating using my right click. I'm holding it and I'm rotating it, right? And I'm working in axon view. You can work in perspective if you like. It depends, but majority of the time I'll work in axon, isometric view. And so after that's done, I'll soften my corners however I like. So the way I would do that is I would type circle command. You can see here it'll say tangent, or I can just type T for short. And this is basically a fillet command, just more manual and more intuitive. I can start to eyeball to see how big my fillet needs to be. Instead of using the fillet, I'd have to know a certain radius, which, isn't that intuitive. It's nice to see it. I'm a visual person. I assume everyone here is a visual person, so nice to see the circle, just like a feeling, to see how big the fillet needs to be. Okay, so once you do that, you'll probably get something like this. You know, I have a range of small fillets, big fillets. You know, I like to think of a hierarchy, or whatever language you're going in, that will determine the kind of vibe that these lines will have, whether it's super soft or super angular. You know, sometimes I'll choose not to fillet something and just seeing how that works with when you sweep a surface. But I'll get into that in a second. So once you have these sweep rails, right, just label as I go, sweep rails. The orange is your sweep curve. And you can have as many sweep curves as you want, but you can only have 2 rails, right? The rail is what holds things together. It's the curves that kind of hold basically the edges of the surface you're going to make, right? And so I have here 2 sweep curves that I'm going to be using to create this surface. I'd like to add a minimum of 2 sweep curves. That way I'll have better control with how they end. You know, if I want it to end flat, I'll adjust how the ends of these rails would end, and then I would connect it with a sweep curve, right? And so once you do that, on top of that, you're free to adjust the sweep curve however you like, using the techniques we mentioned. There's another command called rebuild, which will rebuild your curve, and you can start to control the curvature of this sweep curve, and you'll probably get some interesting results. I find it best not to overdo the sweep curve. Just keep it to like a simple curve. It's more like a profile. If you know the type of profile you want, you would just make it here, right? And so after that's done, I will begin to use the command sweep 2. So I'll type sweep 2. And my first rail, doesn't matter which order the rail is, so I'll select the second one, get the sweep shape, and then boom. And usually you can just click OK after these settings. Sometimes I'll check maintain height. Sometimes it's helpful because it stays, that setting means it stays true to the sweep curve, the way you've drawn it initially. If you don't check it, Rhino is just going to feel free to interpolate this surface however it likes. So when you check maintain height, it'll stay very strict to your initial sweep curve. You know, you could check it, uncheck it, see how it looks. Sometimes checking it does cause some issues when sweeping, so just be mindful of that. Right now I'm using a really simple sweep curve, which is a straight line, so it'll maintain that height no matter what. So yeah, so that's that. It's pretty straightforward. What matters here in surface modeling is your sweep rails, right? So what I just performed was just a simple, like, I just swept a curve through these 2 rails, right? Sometimes you'll want to get more specific, and you'll probably want to have a cleaner geometry. So in that sense, you kind of would be mindful to what 2 sweep rails are you sweeping. So it's not a matter of just like drawing randomly 2 rails and you just sweep it, right? Sometimes you want to be mindful of how the surface connects to each other. So right here, you'll see this and you'll see this. Ideally, this line and this line relate to each other as how it creates the surface, right? And this relate to each other in terms of how they make, right? So if I were to just sweep this in one go, for instance, Rhino will just, in this case, Rhino naturally knew where the seam of each of these subsurfaces will be, and it knows to like take this and connect it together, right? However, in the case like this is a straight line trying to loft against a bent line. And so you'll see this seam, it'll kind of just land on a random spot on this surface, right? Now, ideally, you would want to control pretty much all aspects of your modeling, right? So this is just an extra step to sort of have you understand how this really works. So now, if I want to add like a softer bend to it, now sweep that. You can see that Rhino does its best to create this surface between these two rails, right? And you can see how it kind of, you see these lines, right? They're called isocurves, and these are just, it's basically the DNA of the surface, which helps Rhino kind of create this surface, right? It's kind of like Rhino assigning its own sweep curves so that it can help itself create this surface, right? Because since I didn't assign any sweep curves here, Rhino took the liberty to create its own, and those are the lines that you see, right? But I'd rather, it's much more clean if I were to select these fillets and just assign them together. And I take this, well, let's pretend I don't have this point anymore. I can just delete it. And this. So what I'm doing is I'm holding Control-Shift. That way I'm able to select my sub-objects. I'll loft that. And so you'll see this is a much cleaner surface. And then from there, I'll join it. And so I essentially got the same surface. Actually, one second. So here I know this and this can come together, and you know, in this case you can see that I chose the sweep curve. So in this case, this doesn't really have another radii to pair itself to. So what I could do is a command called extrude curve to point. And I basically choose any point on this line. And it just gives me more control. And then from there, I can split this. So now I have either that or insert control point. So I'll insert a control point here. And this can now loft cleanly. Oops. So now this is a much more cleaner surface rationalization than just letting Rhino do the work. So yeah, the rule of thumb here to think is like line usually pairs with a line, a radius usually pairs with a radius. When nothing else can be paired to it, I usually just extrude it to a point. Or you can extrude it to a line, a radius to line. I guess the key to this concept is that when you sweep, it's best to break it down and to see like what can be paired with what. And in that case, you'll just sweep, or in this case, loft individually to create a cleaner surface. So that's that. With that said, the second way of surface modeling is the rebuild option. You draw the line, and then after that, you would rebuild the line. And you can add as many points as you like. Ideally, I'd keep it pretty simple, but depending on how complex this edge or line is in your geometry, you'll just add more to it. So as long as you set the curvature degree to 3, the curvature is already embedded in the line, right? So whenever you insert a control point, that control point isn't just like a bent, it won't bend the line, but it will actually be a part of the curvature of the line too. As opposed to if I inserted a control point on a normal polyline, it will bend my geometry, right? Because there's no curvature embedded in a line. But when you rebuild it, you can embed a curvature degree in the line. And this is how you'll get that control in kind of manipulating the line, the curvature of the line. So with that said, as you can see here, I rebuilt this line. I inserted some control points to sort of edit my curve. The fewer the curves, the more loose the curve is going to be. But the more control points you add, you can start to tighten up some of these curvatures and these bends, giving you more of that control for your curve, right? So if I add here, I can start to control how sharply it bends. And whenever you have 2 control points in the same direction, it will automatically create a line. The moment you introduce a third control point between 1 and 2, that's when you start to create curvature. And a fun fact is if the distance from this and this is the same from this and this, you'll essentially create a partial circle. It'll be a partial arc. So the way this works is basically Rhino, you can basically recreate a circle from this jump. Because if I go here, and you can see this arc that I created from a circle, these two are equidistant from this, right? So just something to keep in mind, just an additional fact. And then here, after you manipulate your thing, you could do a sweep 2. In this case, I opted for a simpler surface build, so I just lofted it. And loft is just a very straightforward command. You can select as many curves as you'd like to loft, and it's pretty much done. And I can just click OK. So that's rebuild. Here is the revolve command, and I can revolve a curve as I like. I choose a starting angle, and then I just move and stop it wherever I'd like. I can even type in the degrees I would like, maybe like 30 degrees, 120, to get more precise, okay? And then you can start to think about how these shells can start to interact and start to create spatial complexity. I just did something quick where I just trimmed a shell with another revolved the shell, and I created a pocket. I can just, keep that there. Oh, it's a mosquito. And then I kind of extended these planes out because it's nice to read this concave against a flat surface, and vice versa, convex surface against something flat. Which is ideally how you should be thinking about when you make these things. It's like, how do these voids and volumes read against each other? And how can they help each other read? Right? You kind of need a reference point for these things to read, and so that's kind of the purpose of these flat planes, right? So that said, this last surface modeling technique it's very similar to sweep 1. And sweep 1 is pretty self-explanatory. You have only one rail instead of two. So this rail, and then you can select your sweep shape, and it will try its best to sweep your curve along this. It'll rotate and do whatever it wants with this sweep curve to achieve this surface, right? So another way you can do it is it's called extrude curve along curve. And extruded curve along curve does not change the direction of the sweep curve. Instead, it kind of just maintains the same direction as it goes along the rail. And you'll see so select curves to extrude, it would be this. Enter, select the path curve, it's just another name for a rail, near the start. So I clicked here, and as you can see, even though a Rhino constructs its own sweep curves, it's always maintaining the same direction. It doesn't change the rotation at all. As you can see here, if I do a sweep 1 again, it's trying very hard. You can already see in this iso curve, it's trying very hard to be as adaptive to this rail as it can be. If it bends a corner, then it must rotate the curve and so forth. So that's sort of the difference between the two. And both can provide different effects, sometimes one better than the other. You just kind of have to try both. Okay, so here now we're going to talk about stereotomic. So before we begin, this is another recommended shortcut. Right now I'm in orthographic view, which just means flattened, no depth, no perspective in the display, right? And when I pan around, I'm pretty locked in, but when I want to switch from 2D to 3D, what I'll do is I'll hold Control Shift and do my orbit command, which is the right click, and I'll let go of Control Shift and I'll be back in 3D space. Usually when I do this method, I'll always be in isometric 3D space, meaning there's no perspective. It's all isometric. And when I want to snap back into an orthographic view, I'll choose the closest, I'll orbit to the closest I can to the view I want. And Rhino, when I hold Control Shift, it will snap. You see. Now if I orbit closer to this elevation and I hold Control Shift, it will snap there. Oh, whoops, sorry. Yeah, so it'll definitely snap, but then I still have to hold Shift and then right click to move it and pan it. But then I can just reorbit out of that site. And this is very helpful in modeling things three-dimensionally. This will make you Rhino Pro in no time. So snappy gumball and this shortcut, you'll be able to maneuver Rhino like a pro. So with that said, let's start. So we'll have I could start with a pretty primitive geometry like a box. It could be a sphere, it could be anything. And then I will draw however I would like. I'll draw whatever diagram I'd like using the techniques that we talked about before. And then step 2, I can choose to extrude those lines and just Boolean split it from there. I could either do that, or I could use one of these surfaces and I can create my own surface that I would like to split apart. In this case, I'm splitting it apart from the side, and I'll still get a closed polysurface geometry that has all the surface conditions I want. And this will help to create your carving much more dynamic. I can start to think about it. How can I then split it from the side like this? So I can start to break up that silhouette so it doesn't stay as a straight rectangular edge, but it can become something that's more dynamic. Remember, the Boolean split plane has to be larger than the volume you're splitting itself. I'll just do this for the heck of it. Hopefully it works. It does. And boom, as I rotate around this object, I could start to see it having so many different conditions. And it's nice that I use the same Boolean split plane, right? Because you don't want to throw in like a bunch of different languages, design languages, into one object. You kind of want to stay consistent to the language you already developed with the surface already. So ideally, it's using the same surface to split the object in different orientations is recommended. Because it helps to keep your piece consistent looking. So, after you split it, you can use your basic commands as like you hold Shift, Control Shift, and you can select a sub-object like a face or an edge. I'm just holding Control Shift and I hold it and I can, edit this however I please, after splitting it. And then I'll just continue carving accordingly, right? And so now I'm going to switch my orthographic view. I'm going to use that technique I mentioned in the beginning of this and just do Control Shift near the view I want, and I'll snap to it, and I'll hold Shift to pan around, right? And now I want to be able to use the model in the background as a reference as I draw how I want to start to carve this. So you notice how everything I've drawn in this section kind of aligns with the geometry in the background. So what I want to do is I want to adjust the C-plane, which is a reference plane that you can draw things on. Right now, the default is the top-down plan view, but I want to change it to this. So Rhino 7, what I can do is assign a C-plane. So I type C-plane, and here it says object. And since I already had the object selected, it moved the C-plane to this reference plane I have here, right? And then what I'm gonna do is I'm going to change the object display setting. So set object display mode, and I'm going to change it to ghosted, right? Right now my entire view is in shaded, but I can select specific objects and change it into any view I'd like. I can change it to Arctic mode. I can change this to ghosted. I can change this to, wireframe, right? It's a pretty neat command, but in this case, I'm only going to be using it for this C-plane, right? Default, it was already in shaded view, so I can't really see through it, so it's not going to be helpful. So I want to do it in ghosted, okay? And after I do in ghosted, I'm going to lock it, so I can't move it. I'm going to lock it. I'm going to snap into my orthographic view. And then down here, I'm going to click project so that anything I draw, right, it's going to stay on that C-plane, right? And this is so important. It's going to help you carve your pieces. It's going to help you in the future, making section chunks. It's great to just be able to draw in front of your 3D model. And you're also able to snap to edges if you have snappy gumball. So everything's very precise. Yeah. So you draw that, I can start trimming away, start doing my thing, start drawing this curve how I want it. I'll end up with something like this, right? And then I'll extrude it, do the same process, Boolean split. I've typed everything here. Hopefully it's helpful. I should probably add, and then Boolean split. I guess it applies to every step here, but. And then I'll just continue carving away, using this technique. It doesn't have to be such an extrusion. It could just be something that's dynamic. The surface can have certain qualities that we've talked about, here, right? Just be mindful of how much you're doing, You don't want to put in all that work when you don't have to. So just stick to what it is you actually want to model based on your AI image, and hopefully these techniques can help you get there. So with that said, I switch the view using the same technique, right? I'll probably do it here really quickly. So right now, I don't want to stay in the C-plane, so what I'll do is I'll type C-plane, world here, top. That's my default C-plane. Then I'll just redraw everything, shut off project for a moment, set the C-plane, object, and now I have this, but it's unshaded, so I don't want that. I'm going to change the object view to ghosted. I'm going to lock it. And now I'm able to see through it, and I can turn it on project. Project just makes everything flat on the C-plane, right? So I have project, I can just draw anything I want, but it will always be on the C-plane. Yeah, so very helpful. Yeah, just draw however you want. Boom, extrude, carve, right? And then once I'm done with this view, I'll reset the C-plane back to world. Top. And yeah, and there we go.